Robotics has THFURA batlified LR80RV'd. Imagine entering a city devastated by war. But instead of human scouts moving ahead of the main force, the first thing entering the ruins is a four-legged machine. It moves across broken concrete, climbs over obstacles, carries cameras and sensors, and in some publicly demonstrated configurations, even weapons or other military payloads. Above it, drones watch the entire battlefield. Human soldiers remain farther behind, receiving information and maintaining control from a safer position. It may sound like science fiction, but in recent years, China has publicly demonstrated several four-legged robotic systems designed for potential military applications, and they reveal a new direction in modern warfare, sending machines into dangerous areas before sending humans. At first, many people may ask a simple question. Why does an army need a robot dog? Why not simply use a tracked vehicle or a wheeled robot? The answer lies in the battlefield itself. War zones are rarely flat. There are stairs, rubble, trenches, collapsed buildings, and narrow spaces filled with obstacles. A wheeled vehicle may struggle in these environments. A four-legged robot, although still limited in many ways, can potentially step over obstacles rather than simply trying to roll across them. In theory, it can become a combination of several different systems. A reconnaissance robot, a small transport platform, and a mobile carrier for military equipment. The most dramatic images, however, are those showing robot dogs equipped with weapons. In public demonstrations and military exercises, China has shown four-legged robots moving alongside soldiers while carrying weapon systems. But there is an important distinction that must be made. A robot carrying a weapon does not automatically mean that it is an autonomous killing machine. A robot controlled by a human operator is very different from a system capable of independently identifying a target and deciding to fire. Publicly available footage may demonstrate the mobility of the platform and its ability to carry weapons, but the actual level of autonomy, and especially who controls the decision to use lethal force, cannot always be determined from a short video clip, and that distinction may become increasingly important in the future. But weapons are only one part of what makes these robotic platforms interesting. Their real advantage may be their ability to carry different types of payloads. A four-legged robot could potentially be configured to carry cameras, sensors, communication equipment, small radar systems, ammunition, supplies, or other military equipment. From an engineering perspective, a modular platform can be adapted for different missions simply by changing the equipment mounted on it. Instead of building an entirely new robot for every role, the military could potentially use one basic platform and modify it depending on the mission. But perhaps the most significant and potentially unsettling idea is not a single robot dog. It is the possibility of an entire robotic pack. Imagine a military unit moving into a dangerous urban area. The first robot moves ahead to conduct reconnaissance. Using cameras and sensors, it searches for obstacles and possible threats. A second robot carries communication equipment. A third transports ammunition or supplies. Another platform could potentially carry a weapon system. Above them, drones observe the entire area from the air. Information from all of these systems could then be transmitted to soldiers and commanders positioned farther behind. In that kind of battlefield, warfare is no longer simply humans fighting against humans. It becomes a system. Machines observe first. Machines move first. Machines collect information. And humans analyze, control, and make the final decisions. This is the basic idea behind human-machine teaming. The goal is not necessarily to replace the soldier. Instead, the machine becomes an extension of the unit. But despite the dramatic images, robot dogs are still far from replacing infantry. They have serious limitations. The first problem is energy. A human soldier can continue operating with food, water, and rest. A robot depends on batteries or another power source. When the power runs out, the mission may end. The second problem is durability. Mud, water, dust, extreme temperatures, impacts, and battlefield damage can all affect sensors, motors, electronics, and mechanical systems. The third problem is communication. If the robot depends on remote control or external data links, electronic warfare becomes a major threat. Signals can be jammed, connections can be lost, and a highly sophisticated robot may become far less useful if it can no longer communicate with its operator. That is why, at least for now, the most practical role for four-legged military robots may not be replacing soldiers. Their greatest value may come from answering one simple question: who enters the dangerous area first? Urban warfare is filled with blind corners, closed rooms, staircases, tunnels, and the constant danger of ambush. A robot can potentially be sent inside first. It can transmit video back to the soldiers. It can inspect an area before humans enter. and in doing so, it may reduce the risk to the people behind it. If a machine is destroyed during a reconnaissance mission, the military loses equipment. If a human soldier is lost, the cost is far greater. And the future becomes even more interesting when these ground robots are combined with drones. A drone in the sky can observe the battlefield from above. A ground robot can enter places where an aerial drone cannot easily operate, and human operators can remain farther away, receiving information from both systems. When hundreds, or even thousands, of machines are connected into the same network, the battlefield could begin to change in ways we are only starting to understand. And China is not alone in this race. The United States and several other countries are also developing military robots and unmanned ground systems. But the real competition may not be about who creates the first robot dog. The more important question is, who can manufacture them in large numbers, at a low enough cost, with enough reliability, and integrate them into military operations faster than anyone else. Because an extremely advanced robot costing millions of dollars may remain little more than an experimental system. But a robot that is good enough, cheap enough, and capable of being produced in the thousands could genuinely change the battlefield. And perhaps that is the most important thing to understand about China's armed robot dogs. They may not replace infantry. They may still depend heavily on human operators. And many of the systems we see today may still be demonstrations or experimental platforms rather than fully deployed battlefield weapons. But they represent a very clear direction in military technology. On the battlefield of the future, a soldier may no longer fight alone. Above him, drones may be watching. Beside him, robots may be carrying equipment. Ahead of him, unmanned machines may be conducting reconnaissance. And behind the entire force, a network of computers, sensors, communication systems, and artificial intelligence may be processing information at extraordinary speed. China's robot dogs may only be the beginning, because what is truly emerging is not simply a new type of weapon. It may be an entirely new battlefield. One where humans and machines fight together, and where machines may be the first to enter danger.